For generations, we have gazed up at the night sky. We've seen this vast, silent, and honestly seemingly empty expanse. It's like a canvas of infinite black, dotted with the distant cold light of stars. We called it space, the final frontier. It represented the ultimate unknown, a place of profound solitude. Our tiny blue planet felt like a fragile, lonely oasis of life in an impossibly large cosmic desert. The silence from the stars was, well, deafening. It seemed to confirm our deepest fear, that we are alone. This idea has shaped our stories, our science, and our understanding of our own place in the cosmos. We built our world on the assumption that life was a miracle unique to Earth. This perception of a sterile universe has been with us for a very long time. Early astronomers mapped the heavens, but they saw only predictable orbits of rock and gas. Our first telescopes revealed breathtaking new worlds, but they appeared desolate and inhospitable. We sent our first probes out into the solar system, and the images they sent back showed cratered, lifeless landscapes. Mars was a red desert. Venus was a toxic inferno. The outer planets were frozen giants. Everywhere we looked, we found only a profound and chilling emptiness. The universe, it seemed, was not just quiet, it was dead. The grand cosmic story had one protagonist, and it was us. But is the universe truly as empty as it seems? What if the silence we perceive isn't a sign of absence, but a failure of our own perception? Maybe we've been listening for the wrong signals or looking for a kind of life that mirrors our own too closely. The cosmos is vast beyond comprehension, with billions of galaxies, each containing billions of stars. To believe that our small world is the only place where life has taken hold seems almost statistically impossible. It's a conclusion born of loneliness, not logic. The assumption of an empty universe might be the greatest assumption we have ever made. Slowly, almost imperceptibly, that assumption is beginning to crumble. Every new discovery, every strange signal, and every unexpected finding chips away at the old certainty. We're starting to realize that space is not silent at all. It's filled with whispers, with possibilities we never dared to imagine. The final frontier is not an empty void. It's a place of profound mystery. It's a realm where the rules we thought we knew are being rewritten before our very eyes. We are on the precipice of a new understanding, one that challenges everything we believe about life and our place in the universe. The story of our search for life has been a quiet one until now. For decades, our radio telescopes have been scanning the heavens, listening for a single intelligent signal. We've been waiting for a clear, unambiguous message from an alien civilization. But what if life doesn't announce itself with a grand declaration? What if it exists in forms so strange, so alien that we've been overlooking it all along? The universe might be communicating in a language we have yet to learn. The signs of life might not be in radio waves, but in the very chemistry of distant worlds. Recent discoveries have begun to send shock waves through the scientific community. We've found strange chemical signatures in the clouds of Venus, a planet we had long written off as a hellscape. We've detected plumes of water vapor erupting from the frozen moons of Jupiter, from the frozen moons of Saturn, hinting at vast hidden oceans beneath the ice. These are not just geological curiosities, they're potential habitats. They're places where the fundamental ingredients for life as we know it are present: liquid water, energy, organic molecules. The void is not as empty as we thought. It's filled with tantalizing clues. These are not fantasies or science fiction. These are the results of real missions, real data, real scientific inquiry. The WOW signal of 1977 was a fleeting, powerful radio burst that has never been explained. More recently, we've detected methane on Mars, a gas that on Earth is overwhelmingly produced by living organisms. We've found complex organic molecules drifting in interstellar clouds billions of miles from any star. Each discovery is a breadcrumb, a piece of a puzzle leading us toward a revolutionary conclusion. Something is happening out there. The whispers are getting louder. They're turning from faint echoes into a steady, persistent hum. We're beginning to understand that our search for little green men may have been profoundly naive. The universe may not be teeming with civilizations, but it might be teeming with life itself, microbial, resilient, utterly alien. This is a far more profound and exciting possibility. It suggests that life is not a rare accident, but a fundamental property of the cosmos, a cosmic imperative. The question is no longer, are we alone? The question is now, where is everybody else hiding? To find alien life, we first have to agree on what life is. For centuries, our definition was hopelessly Earth-centric. We looked for creatures that breathed oxygen, required sunlight, and lived in temperate, watery environments. We were, in essence, looking for ourselves. But our own planet has shown us how narrow-minded that view is. We've discovered organisms thriving in the most extreme conditions imaginable. In the boiling hot water of deep-sea volcanic vents, in the crushing pressure of the deepest ocean trenches, in radioactive waste, in solid rock miles beneath the surface. These are the extremophiles. These incredible organisms have forced us to tear up the rulebook on life. They prove that life is tenacious, adaptable, and far more resilient than we ever believed possible. If life can survive in the hellish environments of our own planet, where else could it survive? Could it exist in the methane lakes of Titan? Could it thrive in the subsurface oceans of Europa, warmed by tidal forces instead of sunlight? Could life be based not on carbon, but on silicon? Could it breathe hydrogen instead of oxygen? The discovery of extremophiles has blown the doors wide open on the possibilities for life elsewhere. This paradigm shift changes everything. We're no longer just looking for Earth 2.0. We're looking for any environment where the laws of chemistry and physics allow for complexity to emerge. The search has expanded from a handful of Goldilocks planets to a vast cosmic zoo of potential habitats. We're now considering life in the clouds of gas giants, life on rogue planets drifting in the eternal darkness between stars, and even life that could survive unprotected in the vacuum of space itself. The possibilities are as limitless as the universe itself. Our instruments are being redesigned, and our missions are being reimagined. We're building probes that can drill through miles of ice. We're designing labs that can detect the faintest chemical traces of biological activity. We're developing new theories that challenge the very foundations of biology. We're no longer searching for life as we know it. We're searching for life as we don't know it. This is the new frontier of exploration. It's a journey into the unknown, guided by the principle that life will find a way, even in places we once considered impossible. This is not a story about what we might find one day. This is a story about what we are finding right now. The evidence is mounting and the pieces are falling into place. We stand at a unique moment in human history, on the verge of answering one of the greatest questions we have ever asked. The journey is not just for scientists in labs or astronomers at telescopes. It's a journey for all of us. It's a quest that speaks to our deepest sense of wonder and our innate desire to explore. It's about to change our world forever. In the minutes ahead, we'll take you on a tour of the most likely places to find alien life in our cosmic backyard and beyond. We'll explore the rusty plains of Mars, where rovers hunt for the fossilized remains of ancient microbes. We'll dive into the hidden oceans of Europa. We'll dive into the hidden oceans of Enceladus, two of the most promising worlds in our solar system. We'll even venture beyond, into the realm of exoplanets, and examine the wild and wonderful theories about life in the most extreme corners of the galaxy. This is not speculation. This is the cutting edge of science. Prepare to have your perception of the universe shattered. We'll show you the real science and the latest discoveries that are fueling this incredible search. You'll learn about the ingenious experiments designed to detect life from millions of miles away. You'll see the technologies that are making this quest possible. We'll separate the science fact from the science fiction and reveal just how close we are to making the most profound discovery in the history of our species. The truth is out there, and we're getting closer every single day. So buckle up, the journey begins now. Forget what you think you know about space. Forget the silent, empty void of old science fiction. The real universe is far stranger, more dynamic, and more full of potential than we ever dared to dream. What we're about to uncover will challenge your understanding of life itself. The silent cosmos is about to speak, and you will not believe what it has to say. The search for what's alive in space is on, and the discoveries are just beginning. Between the orbits of Mars and Jupiter lies a vast, chaotic realm known as the asteroid belt. It's a region filled with millions of rocky bodies. Small pebbles dwarf planets nearly 600 miles across. For a long time, we thought of these asteroids as nothing more than inert, lifeless rubble left over from the formation of the solar system. They were seen as hazards for space travel. not as potential abodes for life. But, our recent explorations of these small worlds have revealed a surprising complexity. Some of them are not just dry, dead rocks. They're actually worlds rich in water and organic compounds. So far, our search has focused on microbial life, the simplest and likely most common form of biology. But we cannot completely ignore the biggest question of all. Are there intelligent civilizations out there? In 1964, Soviet astronomer Nikolai Kardashev proposed a method for classifying civilizations by energy. This became known as the Kardashev scale. It's a way to imagine advanced species by their cosmic footprint. It gives us a framework to search for intelligence on a galactic scale. A Type 1 civilization is planetary. It harnesses all energy on its home planet. Sunlight, geothermal, wind tidal. We are not yet Type 1. Carl Sagan placed us at about 0.7. A Type 2 civilization is stellar. It harnesses the entire output of its star. The iconic concept here is the Dyson sphere, a megastructure that would enclose a star and capture every watt. A Type 3 civilization is galactic. It harnesses the energy of an entire galaxy. That power is almost incomprehensible to us. Such a civilization could colonize and draw energy from billions of stars. Their technology would be indistinguishable from magic. For over half a century, we have been doing something remarkable. We've been listening. In quiet valleys on remote mountaintops, giant radio telescopes turn their dishes to the heavens, straining to hear a whisper from the stars. This is the search for extraterrestrial intelligence, SETI. It's the most famous, the most romanticized part of our search for life. It's founded on a simple idea. If another intelligent civilization exists, they might discover radio waves. They might use them to communicate, among themselves or by deliberately broadcasting to the cosmos. Our role? Patient listeners. While SETI listens for deliberate messages, another, quieter revolution in alien hunting is taking place. This method doesn't rely on intelligence or technology on the other end. It looks for the fundamental signs of life itself, intelligent or not. The technique is called spectroscopy, one of the most powerful tools in modern astronomy. It lets us analyze starlight and decipher a planet's chemical makeup from trillions of miles away. It's the science of reading atmospheric fingerprints, searching for chemical telltale signs of biology. When a planet transits its star, a tiny sliver of starlight filters through its atmosphere. Different gases absorb specific wavelengths of that light. Capture the starlight before, during, and after the transit, and the missing colors show up as absorption lines. That pattern is a spectral barcode revealing the gases in the air, like doing a chemical analysis across light years. We're hunting for gas combinations that look wrong for geology alone. We stand on a precipice, staring out at a universe far stranger and more wonderful than we ever imagined. The story of humanity has been a series of expanding horizons. We once believed our valley was the entire world. Then we discovered continents, vast oceans. We looked up and realized the Earth was not the center of the universe. We then learned our sun was just one star among billions in a single galaxy. And now, we are on the verge of the next great expansion of our reality. We are beginning to write the next chapter in our cosmic story. The pages are blank, waiting to be filled. The journey continues, and you will not believe what we find next. The search for what's alive in space has truly begun, and the universe is waiting.